Have you ever wished the universe had a shortcut? You know, like a secret tunnel that skips the boring parts of space and just drops you off on the other side of the galaxy? Well, guess what? Such a thing might actually exist. It's called a wormhole. And while it sounds like something ripped straight out of a science fiction novel, wormholes are a very real part of modern physics theories. But here's the million-dollar question. What happens if you fall into one? Could you survive the journey? Would you be instantly transported to a distant galaxy? Or would you be crushed, vaporized, or spit out into a parallel universe where pineapples rule the Earth? Today on Cosmic Clarity, we're diving headfirst into one of the most mysterious and mind-bending concepts in all of cosmology. Wormholes. What they are, how they work, and what would really happen if you tried to use one. So buckle up. This is going to be a wild ride through space, time, and theoretical physics. What exactly is a wormhole? Let's start with the basics. What the heck is a wormhole? A wormhole, also known as an Einstein-Rosen bridge, is a theoretical passage through space-time that could create shortcuts for long journeys across the universe. To understand it better, imagine space as a two-dimensional sheet of paper. You draw two dots, point A and point B, on opposite ends. If you wanted to travel from A to B, you'd normally follow a straight line across the sheet. But what if you could fold the paper so that both points touch? Now, you can just punch a hole through and get from A to B instantly. That's the basic idea behind a wormhole. This idea was first proposed in 1935 by none other than Albert Einstein and his colleague Nathan Rosen. They showed that general relativity's equations allowed for such bridges. But their original model was completely unstable. It would collapse faster than you could say space-time continuum. Still, it laid the groundwork for decades of scientific curiosity, Hollywood movies, and mind-blowing theories. Science behind the magic. Okay, so how does this actually work? Wormholes arise from Einstein's theory of general relativity, which describes gravity as the warping of space and time by mass and energy. According to this theory, massive objects like stars and planets bend space-time around them. The more mass, the more bend. Now, under certain extreme conditions, like near black holes or in the presence of exotic matter, space-time could theoretically bend so far that it folds back on itself, forming a tunnel or a bridge between two separate points. Think of it like this. Instead of imagining space as a flat surface, picture it as a stretchy fabric. A bowling ball placed on the fabric causes it to dip. Now place another ball elsewhere, and it creates another dip. Under the right circumstances, those two dips could connect through the underside of the fabric, creating a tunnel, a wormhole. But there's a catch. Such a structure is extremely unstable. Without something to prop it open, it would collapse faster than you can blink. That's where the idea of exotic matter comes in. Exotic matter. The cosmic duct tape. Exotic matter isn't your average particle. It's not found in apples, cats, or cheeseburgers. It's hypothetical material that has negative energy density, which means it pushes rather than pulls. In simple terms, it would behave like anti-gravity. This kind of matter could theoretically hold a wormhole open, counteracting the enormous gravitational forces trying to crush it shut. Think of exotic matter as the scaffolding that keeps the tunnel from collapsing in on itself. Do we have exotic matter? Number, do we know how to create it? Also number. But its existence isn't entirely ruled out. In fact, the Casimir effect, a real phenomenon observed in quantum physics, hints at the possibility of negative energy under certain conditions. So, while exotic matter is still very much in the realm of theory, it's not science fiction. Not completely, anyway. Stepping into a wormhole. Let's imagine for a moment that we've solved all these issues. We've found exotic matter, we've stabilized a wormhole, and now it's just floating there in space, waiting. You suit up, you approach, you step inside. What happens next? Well, first of all, you probably wouldn't notice much. Assuming the wormhole is stable and large enough, there might not be any dramatic sensation at all. No blinding light, no sudden warp effects, no ominous music playing in the background. You'd simply step through and find yourself elsewhere. Maybe on the other side of the galaxy. Maybe in a completely different time. Maybe even in another universe, depending on how the wormhole is configured. And here's where it gets even weirder. You wouldn't be traveling faster than light. You'd be cheating the system by not traveling through normal space at all. Instead of moving through the vast emptiness between stars, you'd be hopping over it. To an outside observer, it might look like you disappeared and reappeared instantaneously. But from your perspective, you'd have just walked through a door, the dark side of wormholes. Of course, not everything about wormholes is sunshine and stardust. There are big problems. For one, there's the issue of radiation. A wormhole could collect intense amounts of energy from nearby stars or cosmic rays. That energy could build up and create a cascade of feedback, causing the wormhole to destabilize or explode. Then there's the problem of tidal forces. Just like black holes can stretch and rip apart objects due to extreme gravity, wormholes could theoretically do the same. If the tidal forces are too strong, you'd be turned into spaghetti long before reaching the other side. And then there's the biggest problem of all: time travel paradoxes. If wormholes connect not just space but time, meaning one end opens into the past and the other into the future, then we're in serious trouble. That opens the door to all kinds of paradoxes. Like the classic one: what if you go back in time and prevent yourself from entering the wormhole in the first place? That's called a causality violation, and physics really doesn't like that. Wormholes in pop culture. If all this sounds familiar, it's probably because wormholes have been a Hollywood favorite for decades. They've appeared in movies like Interstellar, Contact, Stargate, and countless episodes of Star Trek. In Interstellar, for instance, a wormhole near Saturn provides access to another galaxy, offering hope for humanity's survival. The movie's depiction was actually based on real physics, with input from physicist Kip Thorne, who later won a Nobel Prize. Pop culture often bends the science a little, or a lot. But it's not all nonsense. These stories help make abstract concepts more accessible, and they inspire new generations of scientists to explore these wild ideas further. Could we ever use wormholes? So here's the million-dollar question. Could we actually build a wormhole, or even find one, right now? Number: we don't have the technology, the energy, or the exotic matter needed, but theoretical physicists aren't giving up. Some models suggest that microscopic wormholes might already exist at the quantum scale, tiny fluctuations in space-time that pop in and out of existence. These quantum foam wormholes are far too small to travel through, but they hint that the universe might already have the ingredients for larger ones. And if we ever learn to manipulate space-time on that level, perhaps through advances in quantum gravity or string theory, then who knows? One day, wormholes might become more than just a theory. They might become a mode of transportation. The universe's ultimate mystery. Wormholes are one of those cosmic ideas that sound completely insane until you realize that the math actually checks out. Are they real? Maybe. Are they usable? Not yet. But they represent something incredibly important: the idea that the universe might be more connected, more flexible, and more astonishing than we ever imagined. They force us to rethink space, time, and even causality. They invite us to imagine worlds we've never seen and journeys we've never taken, and they remind us that the universe still holds secrets far beyond our current understanding. So the next time someone tells you there are no shortcuts in life, just smile and think of wormholes. Because maybe, just maybe, the universe disagrees. Thanks for watching Cosmic Clarity. If you enjoyed unraveling the mystery of wormholes, Don't forget to like, subscribe, and hit that bell icon so you don't miss what's coming next. We've only just begun to explore the weird, wild edges of the universe. Until next time, stay curious, stay cosmic.